In this question, we have to find the radian measure corresponding to the following degree measures. The first one is 25 degrees and the second one is minus 47 degrees and 30 minutes. Let's begin with the solution. And the first one is 25 degrees. Now, we know that 180 degrees is equal to pi radian. So this implies that 1 degree is equal to pi upon 180 radian. So we will be using this formula to find the radian measure of 25 degrees. Now 1 degree is equal to pi upon 180 radian implies that 25 degrees is equal to pi upon 180 into 25 radian, which is equal to 5 pi divided by 36 radian. Therefore, 25 degrees is equal to 5 pi divided by 36 radian. Now let us proceed on to the second part. Here we have to find the radian measure of minus 47 degrees and 30 minutes, which is equal to minus 47 and half degrees. So this is equal to minus 95 divided by 2 degrees. Now as we know that 1 degree is equal to pi upon 180 radians. Therefore, minus 95 upon 2 degrees is equal to pi divided by 180 into minus 95 divided by 2 radian. This is further equal to 5 ones are 5, 5 nines are 45, and here we have 5 into 36 gives 180. Therefore, we have minus 19 pi divided by 36 into 2 is 72 radian. Therefore, minus 47 degrees and 30 minutes is equal to minus 19 pi divided by 72 radian. This completes the solution. In this question, we have to find the radian measure of 240 degrees and 520 degrees. Let's begin with the solution. And first let us find the radian measure of 240 degrees. Now, we know that 180 degrees is equal to pi radian. So this implies that 1 degree is equal to pi divided by 180 radian. So we will be using this formula to find the radian measure of 240 degrees. So this implies that 240 degrees is equal to pi divided by 180 into 240 radian. Now we have 6 3s are 18, 6 4s are 24. So this is equal to 4 pi divided by 3 radian. Therefore, we have 240 degrees is equal to 4 pi upon 3 radian. Now let us proceed on to the last part. Here we have to find the radian measure of 520 degrees. Now since 1 degree is equal to pi upon 180 radian, so this implies that 520 degrees is equal to pi upon 180 into 520 radian. So this is equal to, now cancelling. Now 2 is the common factor. So 2 9s are 18. 2 into 26 gives 52. Therefore we have 26 pi divided by 9 radian. Therefore 520 degrees is equal to 26 divided by 9 into pi radian. So this completes the solution. In this question, we have to find the degree measure of the corresponding radian measure. The first one is 11 upon 16 radian and the second one is minus 4 radian. Let's begin with the solution. And in the first one we have 11 upon 16 radian. Now we know that pi radian is equal to 180 degrees. So this implies that 1 radian is equal to 180 divided by pi degree. Now we will be using this formula to find the degree measure of 11 upon 16 radian. Let us find it now. So 11 upon 16 radian by using this can be written as 11 upon 16 into 180 divided by pi degrees. This is equal to, now here we have 2 8s are 16, 2 into 90s are 180, again 2 4s are 8, 2 45s are 90. So this is equal to 11 into 45 divided by 4 into pi, and the value of pi is 22 by 7. So we have 22 in the denominator and 7 in the numerator, degree. So this is equal to 315 divided by 8 degrees. Now dividing 315 by 8, 8 3s are 24, 7 remainder, 5 carried down, 8 9s are 72, 3 is the remainder. Therefore this can further be written as 39 and 3 upon 8 degrees. That is, this is equal to 39 plus 3 upon 8 into 60 minutes and 39 degrees. And this is since in 1 degree there are 60 minutes. Now this is further equal to 39 degrees plus 4 2s are 8, 4 15s are 60, so we have 45 divided by 2 minutes. Now this is equal to 39 degrees plus 45 upon 2 can be written as 22.5 minute. Since on dividing 45 by 2 we get 2 into 22 is 44. So 1 remainder, therefore this can be written as 22 then 1 by 2. So this is equal to 39 degrees and 22 minutes plus half minute. This is equal to 39 degrees plus 22 minutes plus half into 60 seconds. Since we know that in 1 minute there are 60 seconds. So this is equal to 39 degrees plus 22 minutes plus 30 seconds, or 39 degrees in 22 minutes into 30 seconds. Therefore 11 upon 16 radian is equal to 39 degrees into 22 minutes and 30 seconds. Now let us proceed on to the fourth part. In the fourth part we have minus 4 radian, and minus 4 radian can be written as minus 4 into, now 1 radian is equal to 180 upon pi degrees. So here we have 180 divided by pi degree. Now we are given the value of pi, that is 22 by 7. So we have minus 4 into 180 divided by 22 into 7 degree. Now 2 2s are 4 and 2 11s are 22. So this is equal to minus 2520 divided by 11 degree. Now let us divide 2520 by 11. So 11 2s are 22. 3 remainder, then 2 carried down forward. 11 2s are 22. Then we have 10 remainder, now carrying 0. Then 11 9s are 99. So we have 1 remainder. Therefore this can be written as minus 229, then 1 upon 11 degrees, that is minus 229 degrees plus 1 upon 11 degree. This is equal to minus 229 degrees plus 1 upon 11 into 60 minutes. Since we know that 1 degree is equal to 60 minutes, so this is equal to minus 229 plus 60 divided by 11. So 60 divided by 11 can be written as 11 5s are 55, 5 remainder. So this can be written as 5, then 5 upon 11 minute, which is equal to minus 229 degrees plus 5 minute plus 5 upon 11 minute, and in 1 minute there are 60 seconds. So we have 5 upon 11 into 60 seconds. Since in 1 minute there are 60 seconds. So this is equal to minus 229 degrees plus 5 minutes plus 300 divided by 11 seconds, which is equal to minus 229 degrees plus 5 minutes plus, now dividing 300 by 11, we get 11 2s are 22, 8 remainder, so we have 0. 11 7s are 77. Now 3 remainder, so we have 27, then 3 upon 11 second, which is equal to minus 229 degrees plus 5 minutes plus 27.2 seconds, which is equal to minus 229 degrees, 5 minutes and 27 seconds approximately. Therefore our answer is minus 4 radian is equal to minus 229 degrees, 5 minutes and 27 seconds. This completes the solution. In this question, we have to find the degree measure of the following radian measures. Let's begin with the solution. And the first one is 5 pi upon 3 radian. Now, we know that 180 degrees is equal to pi radian. So this implies that 1 radian is equal to 180 divided by pi degree. So we will be using this to find the degree measure of 5 pi upon 3 radian. So this can be written as 5 pi upon 3, and 1 radian is equal to 180 divided by pi degree. So this is equal to, cancelling pi with pi, and 3 into 60 gives 180, so we have 300 degree. Therefore, 5 pi upon 3 radian is equal to 300 degrees. Now let us move on to the last part, which is 7 pi upon 6 radian. Now this can be written as 7 pi upon 6 into, now since 1 radian is equal to 180 divided by pi degrees, so this can be written as 7 pi upon 6 into 180 divided by pi degree. Now cancelling pi with pi, and 6 into 30 gives 180, so we have 210 degree. Therefore, 7 pi upon 6 radian is equal to 210 degrees. This completes the solution. In this question we are given that a wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Let's begin with the solution. And suppose that this is a wheel. Now we are given that the number of revolutions made in 1 minute are 360. And since the number of revolutions in 1 minute is 360, therefore the number of revolutions in 1 second is 360 divided by 60. Since in 1 minute there are 60 seconds, therefore we can say that number of revolutions in 60 seconds is 360, or in 1 second is 360 divided by 60, which is equal to 6. Now we know that when a wheel makes 1 revolution, then it turns through 360 degrees, or we can say 2 pi radians. Therefore we can write that the wheel, when makes 1 revolution, it turns through an angle of 360 degrees or 2 pi radians. Therefore, number of radians turned by the wheel in 1 second is 6 into 2 pi. Since if it makes 1 revolution, then it moves through an angle of 2 pi radians, so we have 12 pi. Therefore, we can say that the wheel makes 12 pi radian in 1 second. This completes the solution. In this question, we have to find the degree measure of the angle subtended at the center of a circle of radius 100 cm by an arc of length 22 cm. Let's begin with the solution, and first let us draw the figure from the given data. Now, this is a circle of radius 100 centimeters and the length of the arc is 22 centimeters. We have to find the degree measure of the angle subtended at the center of the circle. Now, we know that the radius of the given circle is 100 centimeters. We have denoted it by small r. And also we are given the length of the arc, that we have denoted by small l, which is equal to 22 centimeters. We have to find this angle. Let us denote it by theta. So we have let theta be the circular measure of the angle subtended. Now we know that theta is equal to L divided by R. So this is equal to 22 divided by 100 radian, or on simplifying this is equal to 11 divided by 50 radian. Now we have to convert this into degree measure, and we know that pi radian is equal to 180 degrees. Therefore this can be written as 11 upon 50 into, then 1 radian is equal to 180 divided by pi degree. So here we have 180 divided by pi degree. So this is equal to 11 divided by 50 into 180, and the value of pi is 22 by 7. So we have 22 in the denominator and 7 in the numerator, degree. Now simplifying it, 11 ones are 11, 11 twos are 22, 2 nines are 18. So we have 63 upon 5 degree. Now let us divide 63 by 5. 5 ones are 5, 1 remainder, then we have 3 carried down forward, 5 twos are 10, 3 remainder. So this is equal to 12, then 3 upon 5 degree, which can be written as 12 degrees plus 3 upon 5 degree, and in 1 degree there are 60 minutes. So we have into 60 minutes, and this is because in 1 degree there are 60 minutes. Now 5 12s are 60. So we have 12 degrees plus 36 minutes, which is equal to 12 degree 36 minutes. Therefore, the degree measure of the angle subtended at the center of the circle of radius 100 centimeter by an arc of length 22 centimeter is 12 degrees and 36 minutes. This completes the solution. In this question we are given that in a circle of diameter 40 centimeters, the length of a chord is 20 centimeters. We have to find the length of the minor arc of the chord. Let's begin with the solution. Suppose this is a circle with diameter 40 and this is a chord. Let us name the chord AB, which is of length 20 centimeters. Right? We have to find the length of the arc. That is, we have to find this. Let us denote it by L. Suppose that O is the center of the circle. Now let us join O to B and O to A. And since the diameter of the circle is 40, the radius is 20. So OA is equal to OB is equal to half of the diameter, that is 40 divided by 2, which is equal to 20 centimeters. Therefore here OA is 20 centimeters and OB is 20 centimeters. Now we see that in triangle AOB, OA is equal to AB is equal to OB is equal to 20 centimeters. This implies that triangle AOB is an equilateral triangle, right? And we know that in an equilateral triangle, the measure of each angle is of 60 degrees. Therefore, this angle is 60 degrees. This implies that angle AOB is equal to 60 degrees. And 60 degrees is equal to, since we know that 1 degree is equal to pi upon 180 radian. Therefore, converting the 60 degree into radian, we get 60 into pi upon 180 radian, which is equal to pi divided by 3 radian. Now, we know that if theta is the angle and L is the length of the arc, then theta is given by L divided by R, where R is the radius of the circle. Therefore, if we suppose that L is the length of arc AB, which is a minor arc, then we have L divided by 20 is equal to the angle, which is pi upon 3 radians. So this implies that L is equal to 20 pi divided by 3 radian. Therefore, our answer is the length of the minor arc of the chord is 20 pi by 3 radian. This completes the solution. In this question, we are given that in two circles, arcs of same length, subtend angle 60 degree and 75 degree at the center, we have to find the ratio of their radii. Let's begin with the solution. So let us suppose that these two are the circles with center O and O dash, such that R is the radius of the circle with center O and R dash is the radius with center O dash. Now it is given that arcs of the same length subtend angle 60 degree and 75 degree at the center. So let us suppose that AB and CD are equal. So they subtend 60 degree and 75 degrees at the center. So let the arc of both the circles be of same length. Let us denote it by L. Right? And also we have supposed that R and R dash be the radii of the two circles respectively. Now the angles subtended, as we can see, are 60 degrees and 75 degrees. Now 60 degrees can be written as 60 into pi upon 180 radians. Since we know that 1 degree is equal to pi upon 180 radians, since 180 degrees is equal to pi radians, therefore 1 degree is pi upon 180 radians. So this is equal to pi divided by 3 radian. So 60 degrees in radian is pi upon 3. Now let us try to write 75 degrees in radian measure. 75 degrees can be written as 75 into pi divided by 180. Now 5 ones are 5, 5 5s are 25, and the denominator we have 5 3s are 15, 5 6 are 30. Again 3 is the common factor, so 3 5s are 15, 3 12s are 36, so this is equal to 5 pi upon 12 radian. Now we know that If theta is the angle subtended by any arc, then theta is equal to L divided by R, where L is the radius. Therefore, for the first circle, whose angle subtended is 75 degrees or 5 pi upon 12 radian, can be written as 5 pi upon 12, that is theta, is equal to L divided by R, and L is L and R is the radius of the circle, so we have L upon R. Now let us write down for the second circle. For the second circle we can write down pi upon 3 is equal to L divided by R dash. Now this implies that R is equal to L into 12 divided by 5 pi, and from this it implies that R dash is equal to L into 3 divided by pi. Now we have to find R divided by R dash, and R is equal to 12L divided by 5 pi, and R dash is 3L divided by pi. So this is equal to 12L divided by 5 pi into pi divided by 3L, cancelling pi with pi and L with L, and 3 4s are 12 is equal to 4 upon 5. Therefore, the ratio of their radii, that is R is to R dash, is equal to 4 is to 5, or the required ratio of the two radii is 4 is to 5. This completes the solution. In this question, we have to find the angle in radian through which a pendulum swings if its length is 75 centimeters and the tip describes an arc of length 10 centimeters, 15 centimeters and 21 centimeters. Let's begin with the solution. And we know that if in a circle of radius r, an arc of length L subtends an angle theta radian at the center, then we have theta is equal to L divided by R. And here in the question we are given that the pendulum swings, and when a pendulum swings, the part traced by the pendulum is somewhat like the arc of a circle. Therefore, let us suppose that the length of the pendulum be equal to R, and this is given to us as 75 centimeters, and for the first one we are given that L is arc of length 10 centimeters, now we have to find the angle in radian. So let theta be the angle in radian. So this implies theta is equal to L divided by R, and L is 10 and R is 75. So on simplifying, this comes equal to 2 upon 15 radian. Therefore, the pendulum swings through an angle of 2 upon 15 radian to describe an arc of length 10 centimeters. Now let's proceed on to the second part. In this part again we have to find the angle in radian through which the pendulum swings if it describes an arc of 15 centimeters. Now let us suppose that here L is equal to 15 centimeters. We have to find theta, and theta is given by L divided by R. L is 15 and R is 75. 15 5 is 75, so this is equal to 1 upon 5 in radians. Therefore, the pendulum describes an angle of 1 upon 5 radian to describe an arc of length 15 centimeter. Now proceeding on to the last part, where the arc is of length 21 centimeters. So let us suppose in this case that L is equal to 21 centimeters. We have to find theta, and theta is given by L divided by R. That is 21 divided by 75. Now 3 is the common factor. 3 sevens are 21, and 3 into 25 gives 75. So this is equal to 7 upon 25 radian. Therefore, the pendulum swings through an angle of 7 upon 25 radian to describe an arc of length 21 centimeters. This completes the solution.